Good afternoon, folks. Scott Kelly, account executive from Cloudera, located here in Pittsburgh. Welcome to the third session of the afternoon. So have a great session coming up here. So just real quick on Cloudera for those that weren't in the room before. So Cloudera is basically the modern platform for machine learning and analytics. Our software runs both on-prem and in the clouds. All the use cases that you saw earlier today are probably running on some version of open source Hadoop technology or whatever. And that's one of the things that Cloudera does. So very happy to have you all here. We have a great session coming up. I like the title here. Andrea, is from the Vice President of Development from CNX, and she's going to have a great session. So thanks, Andrea.
Thank you. Thanks for getting the name right. So I will admit I am not a Pittsburgh native. I'm actually from Alaska, so hopefully I won't butcher the title too badly. Hey, Jens, think Tesla's cool? Well, wait till Jens hear about CNX. About. It turns into a Canadian accent at some point. Sorry about that. So, a lot of times when we think of big data, we don't necessarily think of oil and gas. And as we mentioned here, my name is Andrea Passman. I'm actually the Senior Vice President of Engineering and Operations at CNX. And you're probably wondering, why is the ops engineering person up here today instead of the IT people? They're here with me today. But it's really because the business is really driving data analytics and what we're doing. And it's that partnership with IT. And when we think of data analytics, we don't just purely think of statistics and the normal things that are out there. We think of it as a combination with physics. And physics are really what's driving production in the oil and gas industry. So it's you have to have those two to really be able to unlock sort of what's going on from an industry perspective. So CNX, a lot of you may be thinking, who the heck is CNX? CNX is a 154-year-old startup company. It actually used to be a part of Consol Energy, the coal company that all of you know. And about a year ago, we split the two companies. And Consol took the Consol name and the coal mines with it. And the oil and gas side went with CNX, which is where we're at today. So when we think of CNX as a startup company, and we think of our big data and analytics projects, it's much like what you see out in the high-tech industry. We use seed money to fund prototype projects that either take off and we run with them, or we fail fast and we ditch them and we move on. So it's that same sort of type of tech mentality. And about a week ago, I was speaking at the Society of Petroleum Engineers annual conference in Texas. About 10,000 people go to this. And one of the heads of Saudi Aramco got up in front of everybody, and the theme of the entire conference this year was big data. So, oil and gas is known to be a latent adopter of these technologies. And one of the heads of Saudi Aramco got up in front of everybody, and he said, yeah, we may be one of the biggest oil producers in the world, second to Russia, but US small oil and gas companies are eating our lunch because of big data, because of innovation, because it's so easy to make that gain and to make that change. And when we think about CNX and really what's happened, we've really been engaged with this about 2 years, and we've already caught up to the industry leaders that are out there. And those are companies like Devon and EOG. So today, I wanted to make this kind of fun and really start to think about our data-driven approach. And I wanted a full-size Tesla, but they said it wouldn't fit in the room. So instead, I have this nice little one, and it does make noise and runs. Oh, okay. So this will be our great analogy for the day, since we're all very familiar with how cool Tesla is. I happen to think oil and gas is cooler than Tesla, but that's my opinion. So we're going to get under the hood here and take a look, even though there's not really anything under the hood. And let's start firing on all cylinders, all right? Okay, so typical cautionary language. If you really want to understand this, we need some natural language processing. Anyone? Not so much. Okay, so when we think of Tesla, let's have a little bit of interaction because it's after lunch and I had the brownie, it was delicious, right? So we might be a little tired. So when we think of big data and analytics in Tesla, what type of technologies do we think of? Anyone? Please don't be quiet. I'm sorry.
Obstacle detection.
Thank you. Any others? AI. Thank you, Ravi. Thanks, buddy. Neural nets, machine learning, prescriptive analytics, predictive analytics, natural language processing, image processing, ETL. I mean, like, you think of this massive world of technology that's being applied to Tesla. And these are the same technologies that we're employing in oil and gas, the same technologies that we're employing at CNX. And so today, rather than go through like one use case, we decided to talk about some of the parallelisms between the features of Tesla and some of the things that we're doing at CNX and in oil and gas that are really taking advantages of these technologies. And you'd even be shocked to see, like, when you come to CNX on Monday, we even scrum on Monday mornings to get people, like, what is the next step that's available. So not that different. So let's jump into it. So a cool feature of Tesla is the auto summon, which is, hey, Tesla, go park yourself, or hey, Tesla, turn yourself on and get over here and pick me up. Really neat feature. And when I think of that, it's really cool, because this is where neural nets and machine learnings come into place and all of this automation. Well, our wells in the field do the same thing. Granted, they stay parked. Our drilling rigs actually walk and move. They're mobile in terms of themselves. They don't even require trucks, they do it themselves. But when it comes to the wells, we actually have a high level of automation in the wells. And what's really neat about that is that for each of our pad, and a pad is like a mini little plant, like a little mini factory of innovation center out there. It can have anywhere from 4 to 18 wells on it. And these mini plants collect about 7 to 15 gigabits of data per second. And there's about 80 pads within our fields of operation. So when you think about that much data and combing through that, the wells actually know before they're going to shut in if they have any challenges, or what they need to do to auto-correct in the field before something is actually occurring. And then also we can control them, and we can tell them to turn themselves back on if they've turned off and they're not flowing gas. And we call this actually a level of automation, but it used to be that we sent people everywhere in the field to do all this work for us. And now we call it well tending by exception. So only when the algorithm can't correct itself at the wellhead do we actually send somebody to the field to intervene with it. It's a completely different paradigm shift from an industry perspective, especially one when you think about our industry. You normally think about guys in overalls driving around in pickup trucks in the field with really, really, really large wrenches, that most of us can barely pick up. But like now we're moving into this world of AI and automation, and this is one of the forefronts of where the technology is really driven, and some of the early adoption even that we're seeing across the industry. Over-the-air updates, right? Tesla talks about it doesn't really have a maintenance program. It's a software update, and they send that over the air, and that way if there's any challenges with the operating system within your vehicle, you can have that update. And it's really no different when we think about our production control room. So at CNX, in the basement, we have this real-time operating center down there where we can control all of our wells. We have a digital twin out there where we can see everything that's going on in the field. And not just our wells, but our midstream and our pipelines and our production facilities that are out there as well. All of that is controlled from the production control room. And when we think about the technologies we're employing, this is really augmented intelligence. So, we have machine learning and AI that sends the necessary update parameters down to each of the production facilities, because although they're similar, they're not all exactly alike, because each of the areas is different depending on what the rock is, depending on if we're producing just gas or gas and condensate or liquids within the systems. This used to take hundreds of people in the field. And what we've done is we've taken that guy that's out there, typically a GED guy that's just been in the industry for a while, and now we've pulled him into the office and we've retrained that individual to work within the interfaces that are doing a lot of the legwork for them to understand and manipulate the data. And now, instead of that individual maybe only going to see 10 to 20 wells a day, they're managing hundreds of wells at a time from a single interface. Also, they're not putting themselves in harm's way. They're not out there in the elements, and they're able to control everything from an outside environment. So really, it's this idea, of not adding more people as we add more wells. For example, in our Ohio operation, we grew production by 260% last year without adding a single field operator to that. All of that was done through automation, through machine learning, through the AI interfaces so that we could control it from the center. A real game changer in terms of the mindset and efficiency that's out there in the field. Furthermore, as we continue to grow this, we're moving towards edge computing, where there's these little mini innovation centers out at each one of the pads and the factories that are out there so that we can push it even closer to the field level. This is a really favored feature, right? I think among everybody, if anyone talks about Tesla, it's always the Autopilot feature because it's one of the coolest features that they have. And at CNX, when we think of Autopilot, we think of that everywhere across our business. In fact, we're working with local partners like Gray Matter, a CMU company. A lot of you, I think, work with them as well. And this is really to ensure that our wells, our production facilities, our sites are doing self-correction before there's any anomalous behavior that actually hits them. For us, where we make our money, it's all about uptime, right? It's all about production and making sure that our gas is going to sales as much as possible. So any downtime in a well, any non-productive time, NPT dramatically hits us. And that's really where we're trying to focus in this information. This is where we have the digital twin of every facility that's out there. We're also doing things in terms of our pumps that we put downhole that lift the gas up. We're reading about 1,000 data points per second utilizing microphones and acoustic sensing that gather that acoustic data for our pumps and then auto adjust the pumps so that they're not constantly running and wasting energy, because most of this runs off our own natural gas, right? We want to be as efficient with our own energy as possible. So I don't know if you guys knew this, but more cowbell is a real feature inside of Tesla. I know a lot of people start thinking SNL. I'm a big fan too. But the more cowbell is part of the Autopilot feature. And it actually puts up this really cool rainbow road. Kind of looks like our seismic interpretation over here, and then you drive the rainbow road. We like to think of our more cowbell as geosteering. And geosteering, this is about one of the coolest technologies in the world. As you know, within the oil and gas industry, especially with unconventionals, there's a couple big changes. Hydraulic fracturing came in, there was horizontal well drilling, and our ability to stay within a very tight, narrow zone is key. And a lot of times when people think of oil and gas, they think of like a giant swimming pool under the ground, when in fact, it's a really tight rock like a sponge. And we have a very specific target that we want to hit. Through analytics, especially predictive analytics, our geosteering tools are able to stay in zone because the rock wants to pull those giant motors, the bottom hole assemblies, out of zone and pull it in a different direction. We know through regression analysis that the more we stay in zone, the better, more productive well that we are going to have. So what does this mean for us? This is where it gets cool, because I don't know of too many technologies that could do this. You drill 2 miles down. Some of our wells are even 13,500 feet deep. And then you drill 2 miles out and you hit a target within a 10-foot window. That's amazing technology. And furthermore, you just spend anywhere from $6 to $10 million hitting that target. So you want a return on that investment. I know a few years ago, I got my MBA at the University of Denver, and I sent one of the cohorts to an R&D facility for a geosteering company over there because of big data and because of analytics. And they came back and they said that was one of the most mind-blowing things they've ever seen because of all of these technologies coming together to really drive geosteering to be able to drill our wells effectively. Parking assist. I know I need this one in Pittsburgh really badly. It's very difficult to park, especially in Lawrenceville. When we think of parking assist and that ability to make sure that we know where we're at with all that image assistance, we're utilizing drones in the same way. Right now, we're running drones that do our leak detection through image processing. We're looking for not only leaks, but corrosion. We're looking for movement in the pipelines to see if there's going to be any challenges coming in the future. We're also looking for old, undocumented wells. We talked about being a 154-year-old company. The Drake well is pretty old within Pennsylvania, and there's a lot of really old wells out here that we need to identify and find. And that's how we're utilizing drones to find that information as well. We're utilizing the drones to gather our geospatial data so that we can understand where we want to put pads so that we don't have to remove as much soil. Pull that information in and also look at topography so we can do full mapping of areas. There's so many different uses of where the drone technology is going. And also, once again, eliminating people, or not eliminating people, but eliminating them from being in harm's way and in a difficult environment for which they work. They can control that from the drone. Robotics. So when I think of Tesla, I definitely think of robotics that build, not only these little cars, but the really big cars as well. And specifically, I think of robotic process automation, RPA. We recently got our first robot. We named him Gaston X Autowell the First. I thought that was funny. And he's got a parking spot. He works at the gym. The good thing about Gaston is he never calls in sick. He used Teladoc for his last virus. Okay, this is going nowhere. But RPA, for us, when we talk about oil and gas, typically when you talk about people in our business, we call them hands, because it's hands that are out there doing all the work in the field. They're the ones moving the iron. They're the ones moving pumps. And instead, we call them brains now, because with RPA, we can take a lot of that manual effort that they were doing, things going out and scrubbing sites, pulling that information, doing some cognitive analytics to it, putting that in another place. That can now be replaced with RPA to free up their time so they can spend more time working on problems. Beyond robotics, there we go, I think of collision avoidance. Right? And when I think of that, I really start to think about where machine learning gets really cool. And we do a ton of work on big data sets, not only our own wells, but all the wells that are out there in terms of production data, location, hydraulic stimulation data, drilling data. We pull all that information in. Back in the day, we used to call some of this just like regression analysis. Everybody likes to put new terms out there, but really what we're talking about is an extreme random forest to develop insights into this massive data set so that we're not drilling wells that are too close together and bumping into each other, and that we're putting effective stage spacing in, interlateral spacing. It's optimization of all of this, and it's very, very early on. This is when it gets really cool. So the long-distance bioweapon defense electric engine. You think of Tesla and the electric engine. They call their bioweapon defense mode when it cleans the air. So at CNX, we just signed an agreement with a company called Evolution. Evolution is an electric frac. It's a GE turbine engine that runs off of our own natural gas. It's extremely clean, no diesel. The footprint is half of what it previously was for a hydraulic stimulation crew. We used to put 24 pumps out there, now we'll have 8. It used to take 20 people, now there's 10. Everything is controlled from a central site. It's all automated through data analytics. We can get vibration data off of our pumps to know what's gonna go down ahead of time and prevent that from even occurring. It's a complete different paradigm shift in terms of our industry and where we're going. And it allows us to efficiently speed all that time up. And what used to take us like a year where we would be out on a pad in a facility for like a year doing operations, we can almost cut that time in half. Then it gets really cool, and this is where they used to call this insane mode, and now it's ludicrous mode. But this is where we're combining all of that data to get a 3D view of what's going on. And this is through neural nets and cloud computing that lets us combine all of that information to make major insights. And so let me just close by saying, when you think of CNX, you may be thinking like, oh, we need just petroleum engineers and chemical engineers. But it's really those data scientists, those data engineers that are working at the Pittsburgh tech companies that are out there. This is the new Pittsburgh we think of, right? We think of eds and meds, we think of high tech and Uber, but instead we really need to be thinking about shale technology at the same time. And with that, Elon Musk and our CEO, Nick DeIuliis, have some things in common, but I will say that one thing they don't have in common is Nick is definitely not going to let our stock go up in smoke. So with that, I will close. Thank you for your time today. Appreciate it.